Hello everyone. In this question, we are asked to find the value of a sum of n from 3 to infinity of 1 upon n raised to the power 5 minus 5n cube plus 4n. Okay, so this is an infinite sum. Usually such sums require some partial fraction and method of difference. Okay, so let us start. We are given the sum as n goes from 3 to infinity of 1 upon n raised to the power 5 minus 5n cube plus 4n. So let us see if this denominator can be factorized or not. Okay, this becomes 1 upon, if I take n common, this becomes n raised to the power 4 minus 5n square plus 4, right? So if this term can be factorized, then we can write it as 1 upon n times, this can be written as 4n square minus n square. And the product is 4n to the power 4, right? So this becomes n square minus 4 times n square minus 1. This becomes n to the power 4 minus 4n square minus n square, so 5n square and plus 4. Okay, so this can be written as like this. Now this can be further factorized as this is a square minus b square. Okay, so we can further factorize it, and this becomes 1 upon n times n minus 2 n plus 2 times n minus 1 times n plus 1. Okay, so there are 5 terms in the denominator. The largest of this term, this is the largest term, right? N plus 2 is the largest of these 5 terms in the denominator, and this is the smallest, n minus 2. Okay, so usually if we write the numerator as a difference between these two, then the partial fraction is made of consecutive terms. Okay, so if I try to write it as the numerator as n plus 2 minus n minus 2, the numerator 4 is left out. Okay, so since there is no extra 4 here, I need to divide this by 4. Okay, so I have to divide this by 4. Now I can write it as n plus 2. I'm writing the denominator as in a descending order, okay, from the largest term to the smallest term. So this becomes n plus 2 times n plus 1 times n minus 1 times n minus 2, right? I've just rearranged this expression as this. Okay, and summation is from n equal to 3 to infinity. Okay, so this now further becomes 1 upon 4 as summation n goes from 3 to infinity. In the first term, we have 1 upon n plus 1 times n minus 1 times n minus 2, right? And in the second term, we have n plus 2 times n plus 1 times n minus 1, right? Since these terms will get cancelled out respectively. Okay, so now if we start putting the values of n equal to 3 in these terms, okay, we'll get the consecutive terms. So this, in the first case, if we put n equal to 3 in this first term inside the bracket, this will become 1 upon, this will become 4 times 3 times 2 times 1 minus n plus 2 will be 5 times 4 times 3 times 2. Okay, this is for n equal to 3. Then for the next term n equal to 4, we have 4 plus 1 will be 5, then 4 times 3 times 2, and the next term here will be n plus 2 is 6 times 5 times 4 times 3. Okay, and we see a pattern that the second term for n equal to 3 and the first term of n equal to 4 are similar in magnitude, but these are opposite in sign, right? So these will get cancelled out. This is the method of difference. Similarly, this term will get cancelled here. And lastly, the term that will be left out will be the final term where we put n equal to infinity. So for n equal to infinity, the limiting value will be 1 upon infinity, right? This is the limiting value of the very last term. So 1 upon infinity will become 0. So the term will be left out is this first term only, because this 1 upon infinity, the limiting value is 0, is limit goes to infinity. Okay, so we are left with 1 upon 4 times 1 upon 4 times 3 times 2 times 1. This is 4 factorial, right? So 4 factorial is 24. Okay, so the sum now becomes 1 upon 96. So this is the required final value of the sum. Okay, so this was a relatively easy sum. Usually if you practice such sums, this becomes very easy. Okay, so in order to do the partial fraction, you have to keep in mind that you have to usually do the difference between the largest and smallest, usually, in order that these products, when they come out, these are consecutive terms. If these are consecutive terms, then they usually get cancelled out. Okay, so this is it. If you have any doubt in any step, you can highlight it in the comments. Okay, otherwise it is finished. Thank you.